All right. Now, I always get asked, well, why should you speak to this? How come you're qualified to talk about the things you talk about? And they relate to my background in the semiconductor industry. Now, I was field engineering manager for a large electronics company, global electronics company, and I supervised the first release of electronic equipment in the United States, literally the first ones that came in the country. And I had to make sure that they worked when they hit the field. Now, and these are the different types of semiconductors. I'm just showing you this is because crystals are what everything is made of. You're nothing more than a bag full of crystals, surrounded with crystals. Everything that's consists of two atoms together minimum is a crystal. That's all there is to it. And everything virtually does consist that way, unless it's in a laboratory or it's like an inert gas or something. Anyway, here's the key to this whole thing. Solid materials are classified by the way the atoms are arranged. That's where I go, to the atoms, because that's my background now, is to crystalline structure of semiconductors. That's what makes them work. And in your cell phone, everything that you own that is electronic now works with semiconductors, and I'll talk about that in a minute. Anyway, they're all classified by the way the atoms are arranged within that solid. All right, remember that, the way their atoms are arranged. The same atoms in the same solid can be two different things. Carbon is in your pencil and it is in your diamond ring. Same exact identical elemental stuff, it's in different crystalline form. Now, materials in which atoms are placed at random are called amorphous. They're just all floating around together like a bag full of sand. Materials in which the atoms are placed in a highly ordered structure are called crystalline, and we all know what that is, crystals. All right. Now, then you go into polycrystalline materials, and materials with a high degree of short-range order and no long-range order. All right. Now, if you go into all this stuff, these Bravius lattices and all these different things, this is what creates the angularity in crystals. Right? That's why they have this formulas and vectors and all this business. That doesn't mean anything. All you have to know is that crystals arrange themselves in molecules. Well, here, I'm going to show you something that I used to do. Now, I'm not showing this to brag, but this is what I used to do. This is the kind of stuff that I would work on to make sure that, the crystals were right, that they were doing, I just studied this kind of stuff. I didn't really actually need this for the stuff I was doing, but it related so deeply that I got so deep into it I couldn't stop. So that's just what it is. And I never did stop. And I found out that literally everything that's being taught about chemistry and geology and rocks and everything is just not correct, and I'm going to show you why I say that, and this is why I say I can speak to this. This is, and this book is not, this book is filled with this. It's not like one day I did this and that was the end of the day. And plus I have other books here full of formulas and things about different, heat reactions and. I'm pretty deep into this, so I think I can speak to this. I don't think anybody can speak against me about it, and I will speak to anybody about it. So that's what I'm just saying, and that's just the way it is.